Good morning. This is Unit 1, Day 7. We're going to talk about properties of inverse functions today. Graphs of inverse functions are reflected across the line y equals x. Given a function f of x, the notation for the inverse is f, and then it has like a -1, kind of like an exponent, -1 of x. So this is a line y equals x, right here, this purple line. And the original function is this black line right here. And then the blue line is the inverse function. We're flipping it across the line y equals x, which is just a straight line. The slope in front of the x, there's a number that's 1. So we're going to start at 0, 0 and go up 1 over 1, up 1 over 1. That's the line y equals x. The domain of the function is equal to the range of the inverse. The range of the function is equal to the domain of the inverse. They switch. The domain and range switch. If xy is a point, then yx is the point on the inverse. They just switch. The x, y values switch. So I just want to show you that up here. This point right here, 0, 2, is a point on the original function, right? We go left, we don't go left or right, so that's 0, we go up 2. Then if we switch that to 0 is the same point right here on the inverse. To verify algebraically, this might be on the test, that functions are inverses of each other, you must show that the inverse, the composition functions f inverse of f of x equals x. You're going to get x at the end, and the opposite is also true. F of x, or f of the f inverse, is also x. We'll get x both times, and I'll show you this. If a relation and its inverse are both functions, then they are called one-to-one. So if they pass the vertical and horizontal line test, then the function is one-to-one. If each value of the dependent variable correspond to exactly one value of the independent, so if it passes the horizontal line test, then the function is said to be a one-to-one function. That's kind of what I just said. Okay, so let's look at this. It says, for each of the graphs below, draw the line y equals x first. Okay, so this one, y equals x, is a slant line, goes through 1, 1, 2, 2, -2, -2, like this. Okay. Sketch the inverse of the function on the same grid. Which of the functions are one-to-one? So my original function looks like this. My inverse is going to be, if this is -3, -2, then -2, -3 is a point, and -2, -1 is a point, then -1, -2 is a point. It looks like it goes through this point right here, which is 1, 0, then 0, 1 is a point. It looks like it goes through right here, 6, 1, then 1, 6 is a point. Right here. Okay, that looks perfect. So this is my, this is going to be my inverse. And this is my original one. So it kind of like goes up like this. This does pass the vertical line test. It's only going to touch the graph once if I draw any vertical line. And it is passing the horizontal line test. So is it one-to-one? Yes, this function is one-to-one. So I know A is. Maybe there's another one down here that is also. The function for this looks like a square root. So this f of x equals the square root of x. Now we're going to the left 1, 2, 3. So instead of minus 3, it's actually going to be plus 3. And it looks like we're going down 1, 2 times. So minus 2 on the outside of the square root. In order to find the inverse, our first step is to make this a y. Y equals the square root of x plus 3, and then minus 2 on the outside of the square root. And now I'm going to switch the x and y. X equals the square root of y plus 3, oops, and then minus 2. Now I have to solve for y. So I'm going to add the 2 to move it to the other side, plus 2, plus 2. So then I have x plus 2 equals the square root of y plus 3. And then I'm going to square both sides. So this side squared, this whole thing squared, and I get something like x plus 2 squared equals y plus 3. And my last step is to move that 3 over minus 3. So this is now going to be the inverse. The f inverse of x equals the x plus 2 squared and then minus 3. This is my inverse. Sorry, it's kind of slant, guys. I want you guys to try this one. Try B. I'm going to try C. So my function, I know that this is a cubed root. Okay, this is a parent function. It looks like a cubed root. So f of x equals the cubed root of x. It looks like we're shifting it to the left 1, so I'm actually going to put plus 1. I don't think we're going to shift it up or down at all. It asks us to graph the line y equals x, so I'm going to do that. Y equals x is a slant line. Something like that. And it asks us to graph it. So I'm just going to kind of give a rough graph. Look at these points. This is -1, 0. So 0, -1 is a point. This is 0, 1. So 1, 0 is a point. And I'm going to try something down here. -2, -1. So -1, -2 is a point. Okay, and it's going to look something like this, maybe. Okay, kind of reflected across the line y equals x. Now, in order to find out what it looks like algebraically, so we can actually put it in our calculators and look at it, I'm going to first write y equals the cubed root of x plus 1. And then I'm going to switch my x and y to find out what my inverse is algebraically. X equals the cubed root of y plus 1. Now I'm going to cube each side, cube the x, cube this side to get rid of this cubed root. X cubed is x cubed. The cubed root of something cubed, they will cancel each other and we just get y plus 1. And my last step is to subtract 1 on both sides. So my answer is, this is the inverse, x cubed minus 1. That's it. I want you guys to try the next one. Also, I know that this is 1-to-1. It passes the vertical line test. It also passes the horizontal line test. Even though it does look like it might not right here, it will never touch this graph more than once. So C also passes, it is also 1-to-1. You try B. Let me know. Let CM be the cost of dollars in ounces. What do the following statements tell you about your units? Well, they're telling me that M is going to be the dollars in ounces. So this is telling me that I'm going to plug in 12 ounces of mango, and the cost is going to be 0.75, so maybe like 75 cents. Okay, let me try this one. So this one is saying that 75 cents will buy 12 ounces of mangoes. That's kind of what this is saying. Understanding function notation. Suppose W equals P of X is the average daily quantity of water in gallons required by the palm tree of X feet. So X is my height of the palm tree. So if we have 25 feet palm tree, how much is the water going to be? So this is the average daily water needed for so this one it says is in feet. So 25 feet, 25 foot tall palm tree. Let's try this one. It says palm trees are on average Z feet high, and a tree of average height requires K gallons. Represent this fact in terms of P and the inverse. So my average feet is equal to requires this many gallons. Or we can do the inverse. My average given this many gallons is equal to about this many feet. So that's kind of what it's saying. Use the definition of Z and K from part D to what do the following expressions represent? I just want to make sure you guys understand the difference between this. Remember that Z is the average feet of a palm tree. So this is water for double the average height of a palm, and this is double the water for the average height of a palm. So this is 2Z, and this is 2 times your function. I want you guys to try 2 more and try it. Just do 2 of them. Try 2 more, please. I don't expect you to do all these. I really want to go over the procedure one more time of finding an inverse function. Your first step is to make sure that it's 1-to-1. We're going to interchange the x and the y, and then we just solve for y, and then replace y by f inverse. So sketch this function first. I'm going to sketch it, and then we'll do the other ones. Okay, I just sketched this. Remember, it starts at 2. This is the y-intercept, and my x-squared is negative, so it's going to go down, something like that. My first step, I'm going to do rewrite f of x as y equals 2 minus x squared. I did not change anything except for making f of x y. Now, what I'm going to do is interchange x and y. X equals 2 minus x squared. Sorry, y squared. Now, I'm going to solve for y. So in order to do this, I'm going to move the 2 over, minus 2 on both sides. X minus 2 equals negative y squared. Now I'm going to divide by negative 1 because I don't want a negative y. So now I have y squared equals negative x plus 2. And now my last step is going to be to take the square root of each side. When I take the square root of something, though, I have to put a plus and a minus there. So there's a plus and a minus. I'm going to be given now y equals plus and minus the square root of x plus 2. So the square root of x plus 2 usually starts right here and goes out. But because we have a plus 2, we're actually going to shift it to the right 2. Remember, whatever's underneath the square root, we do the opposite of. So instead of doing it to the right, so I actually forgot this is, it was right here. This is a minus. Oops. A minus. So we are going to go to the right. This is our point. 0, 2 is a point. 2, 0 is a point. And our graph is actually going to look like this. Oops. Should have picked some more points. So it is a sideways parabola like this. They want us to verify that they are inverses algebraically. Now this is really important. Remember, if they are inverses, then the inverse of f of x will give us x. So I'm going to substitute in the original one into the inverse. This is my inverse. Plus or minus the square root of negative x plus 2, or you can put 2 minus x, that's fine. I'm going to substitute this in. The square root of, and then this is negative x plus 2, or 2 minus, and then x is our function, so our original function, 2 minus x squared. Oops, squared. Only the x is squared. Okay, so I need to simplify this. This is 2 minus 2, which is 0. So I get the square root of, remember I have to distribute this negative sign, the square root of x squared, which is just x. Perfect. Now we need the other one to be x also. This is what we want. Now I can't take the other one for granted. I need to show both. My function substituted into the inverse function into the original. So this one, my original is 2 minus x squared. And my inverse is the square root of 2 minus x, or negative x plus 2, same thing. So what I'm going to do is I'm just going to simplify this. Square root of something squared is itself 2, and then I have to distribute the negative sign, minus 2 plus x. Well, this is 0, so we get x. Perfect. That's what we wanted. They're both x. That means they are inverses of one another. Alrighty, I want you guys to try this one. That's all I'm going to do today. Let me know if you have any questions. Have a wonderful day.